All right, ladies and gentlemen, class recording has started. So, to review the two problems that I gave you at the beginning, I asked you to do a couple of conversions to convert grams into moles. So, the first thing we do, right, is a conversion problem. So, time sign fraction bar, grams goes on the bottom because we're trying to get rid of grams, moles goes on the top. In this conversion, when we're converting grams of something into moles of something, 1 always goes in front of the moles. That's going to be important later on. So remember that I just said that. Okay? Whenever grams shows up in that conversion factor, where do we get this number from? Average atomic mass. We get that from the periodic table. But Trey, in this case here, right, it's not the average atomic mass anymore. Now it's the what? What do we call this number here? It's the molar mass now, right? Numerically, it's the same number, right? But when we're talking about it in terms of grams to moles, it becomes the molar mass as opposed to the average atomic mass. So when you run that through your calculator, you get this value. Remember, right, this original number that we got here, the 0 doesn't count as significant. So this has one certain digit and one uncertain digit. So we should round our answer to the same. Same thing with chromium, right? Time sign fraction bar, units wise, grams on the bottom, moles on the top, right? Because we're trying to get rid of grams and go into moles. And then 52 is the average atomic mass, which now becomes the molar mass for chromium. 1 mole, right? When we get those masses off the periodic table, it's always in relation to 1 mole. And then we end up with that for the answer. Christine, go ahead.
So for the uncertain and certain digit
Yep.
stuff, should you always use the number that's like given to you and not like the...
For these conversions, yes, because Christine, these values that go into our conversion factors, these are like, they're not measurements. They're like known values, so they don't count in terms of that. So whatever we end up with, or whatever we started with at the beginning of the problem, we should end up with at the end of the problem. Okay, that's a good rule of thumb for doing it this way. All right, good there. Yesterday, we started talking about this idea of stoichiometry. And we said, from the definition up on the board, right, that stoichiometry is mass and quantity relationships among reactants and products. So we start looking at numbers now. We're not just talking about what are the reactants and what are the products. Now we're getting into, if I have a certain amount of this reactant, how much product should I make out of that? Or if I have an amount, or if I need a certain amount of product, how much reactant do I need to start with? And we said that one of the key ideas, key ways that we can do that is through our balanced chemical equations, especially the coefficients. The coefficients of that balanced equation give us a ratio of moles. That's going to be important a little bit later on as well. Okay? General steps as far as solving this problems go, this problem or any type of problem. Start off with, what am I looking for? We need to reach a destination, a final answer. If we don't know what that destination is, making a plan to get there is a lot more difficult. So let's start off with, what are you looking for to begin with? Then, what do I know? Right? That is going to include information that is specifically given to you in the problem, but sometimes it might include information that we have to either infer or figure out from the problem that was given to us. Sometimes it's obvious, sometimes not so much. Once we know what we're looking for and what we know, now we make a plan to get there. Right? How do we get from what we know to what we want to know? In terms of stoichiometry problems, that's a set of conversion factors. And we'll set up the conversion factors in a way to cancel units, the ones we don't want, and give us the units that we do want, just like we've done with conversion factors all along. Then we do it, then we worry about units and certain and uncertain digits and all that fun stuff. Good there. All right. Specifically for these stoichiometry problems that we started working on yesterday, one of the things that we know that is given to us has to be a balanced chemical equation. The balanced chemical equation is an essential piece of information that we need to compare one part of that reaction to another part of that reaction. And we'll go through examples of how to do it here in just a second. Okay? Once we've got the balanced chemical equation, we know what we're looking for, we know what was given to us, then we can go about the process of doing it. Okay? Good there? All right. We were in the middle of a problem yesterday, but instead of trying to pick up right in the middle of the problem, I'd rather work one all the way from the very, very beginning so we can see all the steps. So, in your outline, or in your packet that I gave you yesterday, the first 2 pages are an outline, front and back, right? Then page 3 of that packet should look like this. And at the top, it says intro stoichiometry problems, mole relationships. Okay? Let's go through an example on this sheet because we can see the process from start to finish. So let's do question number 1 on this page. If you did it for homework last night, great. If you didn't, we're doing it now. So, all right. So it says the combustion of lithium is an explosive reaction that produces lithium oxide. How many moles of lithium oxide form from 2 moles of lithium metal? So, let's go through the process. First thing we should do, right? Now, I'll preface it with this. You don't have to do my method, all right? If you see things faster than that, and you can pick out information from the problem and you know how it pieces together, fine. But this process going through, I think, is a way to make sure that we don't skip things, make sure we don't miss important stuff. You don't have to follow my method, that's okay, but if you do, I think you'll get to where you need to be. Okay? All right, so first thing we should do is what's the first step of this process?
Balancing.
Nope.
What am I looking for?
What are we looking for, right? So, based on this problem here, what are we looking for? Based on what's written to you here, what are we looking for in this problem? Good. Anybody? What are we looking for? Rita.
How many moles of lithium oxide form 2 moles of lithium metal?
Okay. How many moles of lithium oxide, right? That's what we're looking for. So, question mark, moles of lithium oxide. And that's lithium oxide from the formula there. Okay? So that's what we're looking for. All right, after we figured out what we're looking for, where do we go next? We know what we're looking for. What should we do next? What do we know? Right? So what's one thing that we know from this problem? What are we starting with?
We're starting with lithium and dioxide.
Do we know how much lithium we're starting with? Okay, so we know that this is what we're starting with, right? That's a piece of information that was given to us in this problem, something to help us get to the end. So that's one thing we know. There's one other thing that we have to know in every problem in order to do these stoichiometry problems. I kind of mentioned it before. What else do we have to know in order to do any stoichiometry problem? We have to have a what? Julie, go ahead. Gotcha. What else do we have to know before we go any further?
I'm thinking that's what type of reaction.
That's not really important as far as doing the problem is concerned. Rachel,
How many moles are
where do we get that from?
the periodic table?
Nope,
Atomic mass?
nope,
No one else?
nope.
Yeah. Oh,
What do we have to do here?
you have to balance it.
We have to have a balanced chemical equation. That has to be one of the things that we know in order to do a stoichiometry problem, okay? Regardless of what kind of stoichiometry problem, we've got to have a balanced equation. Is this equation balanced as written? No, it is not. So go ahead and balance it real quick. It's not real tough. there's our balanced equation for that reaction. Okay? Good there. All right. We've got what we're looking for. It's in blue. We've got what we know. It's in red. Now we put those two things together and get from what we know to what we want to know. And for stoichiometry problems, that means it's a conversion. So we start off a conversion with things that we don't want. For example, this is our quote-unquote bad measurement. So let's start with 2.0 moles of lithium. And then because it's a conversion problem, right, time sign, fraction bar. Units first. What unit has to go on the bottom of that conversion factor? Moles of lithium, because that's what we want to get rid of. So that has to go on the bottom. And then, what unit should we have on the top of this conversion factor? Moles of lithium oxide, because that's what this problem is asking us for. Notice, this conversion factor has moles of one part of the equation and moles of the other part of the equation. This conversion factor is a key part to any stoichiometry problem. We refer to this conversion factor as the mole ratio, because it compares one part of the reaction to another part of the reaction. In this case, it's comparing one of the reactants to one of the products, which is fine. But it doesn't always have to be reactants to products. It can be reactants to other reactants. It can be products to other products. It can be a product to a reactant. Doesn't matter as long as it's all part of the same equation. Now, we've got units here, but we need numbers. Where do the numbers in a mole ratio come from? Where do we get the numbers that goes in here? Nor? From the chemical equation, specifically which part of the chemical equation, Nor? No. What part is going to compare a part of this reaction to another part? The coefficients of that chemical equation, all right? So, that being the case, Logan, what number are we going to put on the top of this mole ratio? 2, because that's the coefficient that's in front of lithium oxide, right? And then what's going to go on the bottom? 4, because that's the coefficient that's in front of the lithium. The coefficients of the balanced equation relate, give us a ratio of one part of that reaction to a different part of that reaction. And now, this one's pretty straightforward, right? Because here, you know that this is going to be 1/2, right? So we end up over here. Sorry, we should do this, right? Mathematically, moles of lithium cancel there, right? And then you run this through, and you end up with 1.0 moles of lithium oxide. Good there. Okay. That's the easiest kind of stoichiometry problem. We refer to that as a mole-to-mole relationship, because it gave us moles, and we're looking for moles. If you go back to your outline, a mole-to-mole stoichiometry problem is basically one step. We take the moles of the substance that we're given, use the mole ratio from the balanced equation, and that gives us what we're looking for. It's basically a one-step problem. Okay? Good there? All right. Next, let's take a look at the back of your outline. Roman numeral number 3. Hold on one second. Let me pull it up so you can take a look at it. All right. So on the back of your outline, Roman numeral number 3, letter A. So, sometimes we'll find that the information that is given to us in a problem isn't exactly in the form that we need it in. So we have to do a little bit more to get where we need to go. For example, part A here, it says, when magnesium burns in air, a combustion reaction produces solid magnesium oxide. How many grams of magnesium oxide would be produced from 2 moles of magnesium? So let's go through this process here. First thing we should do, first step in the process, what should we do? What are we looking for? Maura, what are we looking for in this problem?
How many grams are produced from
How many grams of?
magnesium oxide?
Okay, so let's just stop it right there, right? So, how many grams of magnesium oxide? We're probably going to have to figure out a formula here, right? So, go to your periodic table, find magnesium, find oxygen, when we find magnesium, what ion does it form? What charge does it have? Positive 2, right? When you find oxygen, right? Oxygen has a -2, right? So that means the formula for magnesium oxide would just be what? MgO. Okay, so how many grams of MgO? All right. Now we know what we're looking for. Next, what do we know? What information did they give us to work with here? Julian, what's one thing?
We start with 2 moles of magnesium.
Okay, so we start with 2 moles of magnesium, from 2 moles of magnesium. So we got 2.00 moles of magnesium. Okay? And then, sorry, hold on a second. I didn't want to write that. Cool. It's not random. There's actually a reason why I write things in the color I write things. There it is. All right, so you got that. And then we said that the next thing that we need in the what do we know category always has to be what? It always has to include what as far as this first stoichiometry problem? A balanced equation. Now, they didn't give us the balanced equation here, right? They didn't give us the equation, so we're going to have to do a little bit of work. I will tell you this, right? I will not, on the quiz or on the test, make you come up with the equation. I will give you the equation. You'll have to balance it, but I will give you the equation. But for practice, let's go through and do this, okay? So, first off, there's some things that they gave us to help us, right? When magnesium burns in air, a combustion reaction. We know about combustion reactions, right? What do we know about combustion reactions?
It always is one subject reacting with oxygen.
With oxygen, right? So Julian, what's reacting with oxygen in this reaction? Magnesium, right? So that means our 2 reactants are magnesium and oxygen, right? We said that oxygen always comes as a diatomic, right? So we got to include it that way. And then, as far as the products go, right, pretty straightforward. It told us that this reaction produces magnesium oxide. And we just figured out earlier that the formula for magnesium oxide looks like this. Is that balanced as written? It is not. It's pretty easy to balance though. Okay, good there? Now, let's go through and start doing this. So, our plan for stoichiometry problems is a set of conversion factors. How do we get from what they gave us to what we want to go to? So we start off with what they gave us. 2.00 moles of magnesium. Time sign, fraction bar. What unit has to go on the bottom of this conversion factor? Maura.
Moles of magnesium.
Moles of magnesium have to go on the bottom of this conversion factor. Why, Maura?
Because they have to cancel out.
Got to cancel out. All right, so that being the case, now some of you might be tempted to make this jump. Okay? Some of you might be tempted to do this. Because why?
That's what you want.
That's what you want. And a conversion factor cancels things you don't want and gives you things you do want. There's a problem with doing that in this conversion factor. What's the problem? What's the obvious problem? Just by looking at it. You don't have to tell me why. What's the problem?
You read it in moles and not in grams.
Okay, we've got moles of one thing, right? And grams of something else. Can we have moles of one thing and grams of something else in the same conversion factor? Can't do that. Moles of one thing and moles of something else, right? The masses are different. We can compare moles of one thing to moles of something else. Why can we compare moles to moles? This is an important concept. Why can we compare moles to moles, but not moles to grams?
Because moles are all the same unit.
Moles are the same what? Julie, you're on the right track. I want to make sure we say it properly.
Size.
Measurement.
What? Measurement of what?
Anything. Everything.
What are we measuring when we have a mole of something?
16.
It's always the same number of things. That's what you said, but that's not really what how you said. I know that's what you meant, but that's not exactly what you said. Moles are the same number of something, regardless of how big or small those things are. So when we compare moles to moles, we're always comparing the same number of things. That's okay. But if you have 10 grams of something and 10 grams of something else, that's not necessarily the same thing, right? Because if they weigh different amounts, we might not have the same amount of something or the same number of something. So you can't go from moles of one thing to moles of something else. That's not where we can go first. Okay? But we can compare moles of a reactant to moles of a product. That's okay. That's fine. What do we call this now? This is our mole ratio, right? And Catherine, when we do the mole ratio, right, where do the numbers in the mole ratio come from?
From the balance equation.
Which part?
The
The coefficients, right? So in this case here, we put 2 on the top, we put 2 on the bottom. Not a particularly exciting mole ratio, but still a mole ratio. But when we do our math, moles of magnesium cancel and moles of magnesium cancel, and that would leave us with what unit?
Magnesium or
Moles of magnesium oxide. Is that what this question asked us for? No. So guess what? Time sign, fraction bar. Maura, what unit has to go on the bottom of this conversion factor?
Moles of magnesium oxide.
Moles of magnesium oxide. Okay? And then Maura, what unit's going to go on the top of this conversion factor?
I want to say grams of magnesium oxide, but I think that's wrong.
Okay. Well, what are we supposed to end up with, Maura?
Grams of magnesium.
Grams of magnesium oxide. Is this conversion factor okay?
Oh yes, because it's the same thing.
Because it's the same thing. We can compare moles of something to grams of that same thing. That's what you did at the beginning of class today, right? You compared moles of hydrogen to grams of hydrogen, or vice versa. We can do that. We can have moles and grams in the same conversion factor as long as it's the same formula. Now, these numbers, right? Remember before I asked you to remember something for later on in class?
Yep.
Now's the time.
I got it.
When we have grams and moles in the same conversion factor, Trey, what number comes in front of moles?
1.
1. Yeah! Wow.
Give me it.
Enthusiastic. Even though the coefficient in front of magnesium oxide is 2 in this formula, or this equation, we're not doing that. That's only important when we're dealing with the mole ratio. when we're converting moles to grams, it's always on a 1 mole basis. Now, when we converted moles to grams before, right, what number went in front of the grams unit? The average atomic mass, which is
Molar
really now
mass.
the molar mass, right?
Got it again.
But here, right, this isn't an element, right? But guess what you do if you're talking about it for a formula? Just add them together, right? From this formula, we know that how many magnesiums are there in that compound? 1. And how many oxygens are there? 1. So all you have to do is add the mass of magnesium.
Do you know them added in this class, like off the top of your head?
Yeah, 40.31.
You did it? God, that's
I did do it this morning, but I do know that magnesium is 24.31 and oxygen is 16.0, and so when you add those together, you get 40.31.
Oh gosh.
So we just add those two masses together, add those two molar masses together, and we get the molar mass for that compound. Now, just as a point of clarification, this number right here, if we're talking about the molar mass for a compound, usually we refer to that as the formula mass. Although if you refer to it as the molar mass for magnesium oxide, people will know what you're talking about. Mathematically, moles of MgO, they cancel. And now it's a matter of just running it through. Remember, if you want, you can think of this as being 2 moles of magnesium over 1, right? If that makes you feel more comfortable as it's a fraction, right? Then we're just multiplying fractions. Multiply the tops, multiply the bottoms, right? If you see in your head that these cancel, you really don't have to do anything, that's fine. I don't care how you do the math, as long as you do the math, and you end up with 80.62. Although, Christine, if we go back to what we talked about before, right? In this number, 1 certain digit, 2 certain digits, 1 uncertain digit. So what should we probably round this one to?
80.7.
80.6 grams of MgO.
Would you take points off if we
No, I won't take points off for that right now. No. Because we haven't actually formally introduced that, right? We just talked about it like conceptually. All right. Page 4 of your packet. Page 4 of your packet looks like this. And up at the top, it says, Intro to Stoichiometry Problems, mass-mole relationships. Okay? Let's start with number 4. Alright, so here's number 4. Okay? Seeing as how we have about 5 minutes left until the period, I'm going to walk through this, okay? I usually ask you guys for questions, but I'm not going to in this case. I'm just going to tell you what I'm doing, okay? So I want to get through this before the end of the period. Alright. First, what are we looking for? It says, how many moles of NO are formed, right? So question mark, moles of nitrogen monoxide. Things they gave us. The reaction starts with 824 grams of NH3. So 824 grams of ammonia. That's NH3. And then, if we go up here, right, we said that one of the things that we need in order to do a reaction, or sorry, do a stoichiometry problem, is a balanced chemical equation. This equation is not balanced the way that it is. Okay, so we would here, right? We'll use red. Okay, I'll put a 2 out in front here and a 3 out in front here. I don't expect you to be able to do this as quickly as I'm doing it. So that's 6. That's right. 2 there. We need 2 here, right? Okay, but that runs us into a problem because because now we have an odd number of oxygens over on this side over here, okay? When you run into that problem, generally the solution to that problem is basically just to double everything, okay? So here, we'll make this 4, we'll make this 4, we'll make this 6, and then that leaves us with 10 oxygens. That's going to be a 5 there, so that our balanced equation is 4NH3 plus 5O2 gives us 4NO plus 6H2O. Okay. Like I said, I don't expect you to be able to do it that fast, okay? But you need to balance it anyway. All right, so now let's go through this, okay? We start off with what we were given, 824 grams of NH3. Time sign, fraction bar. The first conversion factor has to get rid of the unit we're trying to get rid of. So grams of NH3 has to go on the bottom. And even though this problem is asking us for moles of NO, we can't put moles of NO on the top, but we can put moles of NH3, because we can convert grams of something into moles of something else. Whenever we do this, right, 1 mole, okay, and then we get this number off the periodic table, that number is going to be somewhere in the realm of 17.03. Okay. What does it have for nitrogen down there? Kathy, what does it have? 14.01, so this would be 17.04, sorry. Based on your periodic table, this will be 17.04. Okay. And then, right, grams of NH3 cancel, okay? And that leaves us with moles of NH3. But we don't want moles of NH3, right? That's not what the question asked us for. So time sign fraction bar. Moles of NH3 is going to go on the bottom here because we've got to cancel that, right? And then moles of NO goes on the top, right? Because this is mole to mole, right? This one becomes our mole ratio. We can compare moles of one thing to moles of something else, right? And in our mole ratio, we get our numbers from our balanced equation, right? 4 is the coefficient in front of nitrogen monoxide. 4 is the coefficient in front of ammonia. Moles of NH3 cancel. The only thing we're left with unit-wise is moles of NO. So then we just run that through our calculator. Basically 824 divided by 17.04. Better have done it right.
What I did was I do that. Yeah, I could do that like even in dance with everyone.
All right, hey, real quick, the rest of that sheet and the rest of the sheet that we started at the beginning of class for homework tonight. Answers are posted on the calendar. Check them out.